Welcome to another video, the same every time, IGCSE Maths and GCSE Maths, looking at the kind of questions that apart from the numbers are the same every time. Now when I'm making these videos, the kind of student that I have in mind as the potential viewer is mainly those students who don't really see themselves as natural mathematicians. So the idea is we're looking at the questions that apart from the numbers are going to be the same on every exam paper. You can learn how to do them, get yourself into the marks, get yourself into the grades without feeling like you're a particularly natural mathematician. And this particular topic, differentiation and stationary points, a lot of people might think that this is a fairly high-end topic. Well, until fairly recently, even on the Cambridge, this topic, differentiation, was on the AS level and did not appear on the GCSE, the IGCSE, until fairly recently. So you might be thinking this is a fairly high-end topic, quite difficult, and maybe these are the kind of questions that if you don't think of yourself as a natural mathematician, you might leave these questions. Now, we can't be doing that. We can't be leaving questions, because if we leave the questions, we don't get the marks. Most of this we can do. Let's have a quick look here. In this particular question that I've chosen, everything really about differentiation is included. So a curve has this equation, y equals 2x cubed minus 4x squared plus 6. Find dy by dx, the derived function of y. Calculate the gradient of the curve at x equals 4, and then there's a part 3 which is just on the next page here, and find the coordinates of the two stationary points of the curve. Right, well, it looks fairly difficult, and the choice of words in this thing obviously makes it seem more difficult than it really is. But first of all, they say find dy by dx. So they're asking us to differentiate this function. Now there are several words for differentiate. There's differentiate, find the derived function, the derivative, but they're being quite nice to us here because we don't need to worry about the words too much because they are saying dy by dx. So basically that means the same thing. So we can do this, dy by dx. Okay, don't be put off by the notation. Dy by dx is just a way of saying change in y divided by change in x. And really all we have to do is remember one rule, which is multiply by the power and then take away 1 from the power. So I've got 2x cubed. If I multiply by the power, 2 times 3 gives me 6. X, then I take away 1 from the power, squared. You just have to learn how to do this. Knowing why it actually works is a little bit beyond the scope of GCSE, IGCSE. We just learn how to do it. Multiply by the power, negative 4 times 2, negative 8. Then we take away 1 from the power, gives me x to the power 1, which is just x. And then if I have a number on its own, this is worth remembering, a number on its own when I differentiate will just differentiate to 0, so I don't have to write it down. So that's it, that's my 2 marks. Dy by dx, the derived function, the derivative, the differentiation, 6x squared minus 8x. Multiply by the power and then take away 1 from the power. So 2 marks there, 2 marks for doing that. Calculate the gradient of the curve at x equals 4. Well, the whole point of doing dy by dx is because the gradient is what it actually tells us. It is a function for finding the gradient. So I've got dy by dx from the previous question, which is 6x squared minus 8x, and they want the gradient at x equals 4, so all I have to do is put x equals 4 into my dy by dx function. So 6 times, everywhere I see an x I put a 4, minus 8 times 4. And that will tell me the gradient at x equals 4. That's what dy by dx is. It's a function for telling you the gradient. So a calculator job probably for this one, 6 times 4 squared minus 8 times 4, 64. So there's my gradient, 64. So already on this, what you might think is a fairly high-end, fairly difficult topic, we've got 4 marks there just for learning what to do using our calculator. Part 3. They're asking us about stationary points. Stationary points on the curve. Well, stationary points are places where the dy by dx is equal to 0. So at the stationary points, dy by dx equals 0. The stationary points, by the way, are when the curve looks something like that. We call that a minimum when the curve has that shape, or when the curve goes like that kind of shape, we would call that a maximum. So that's what the stationary points are. So it's going to be this minimum down here, or that maximum up there. So the stationary points are the places, and this is what you need to remember, when dy by dx equals 0. Now my dy by dx was 6x squared minus 8x, so I have to put that equal to 0. This is worth an enormous 4 marks, isn't it? So we really do need to get these marks here. So it's a quadratic equation, but it does not have the number. So it's just something x squared, something x equals 0. And the way to solve these is to factorize. Common factor for the numbers, 6 and 8, I'm thinking 2 is the biggest common factor. And x squared and x to the power 1, common factor would be the lowest power of x. So 2x multiplied by what makes 6x squared? 3x. 2x multiplied by what makes negative 8x, would be negative 4, wouldn't it? So we have 2 possibilities here, either 2 times x equals 0 or 3x minus 4 equals 0. Now if 2 times x equals 0, then x must be 0. So our first possible x value is 0. And if 3x minus 4 equals 0, so 3x minus 4 equals 0, 3x equals 4, x equals 3 over 4. So we have 2 possible solutions for x. We have 0 and we have 3 over 4. So the question actually says find the coordinates of the stationary points. Of course, coordinates means x and y, which is why I've now written my x values, the x values that we just found, in the answer space in the x section. The x coordinate comes first, of course, and I've erased everything. On a real exam you'd have more space than this, but I've erased everything and I've brought up now the original equation. So the original equation from the very first part of the question, this one, the very first equation they give us, because we know the x coordinates of the stationary points, we now have to find the y coordinates. And to find the y coordinates, I have to put my x coordinates into the original equation. So when x equals 0, y equals 2 times 0 cubed minus 4 times 0 squared plus 6. Well, that's all going to be 0 apart from the 6, so there's the 6 just there. And the other possible answer was x equals 3 over 4. So when x equals 3 over 4, y equals 2 times x cubed. So 2 times 3 over 4 cubed minus 4 times x squared and then plus 6. Type it into your calculator exactly as it looks. So that's going to be 2 brackets. So hold on, 2 and then brackets. Fraction button, 3 over 4. Fraction button to the power 3. And then minus 4 brackets, fraction button, 3 over 4 brackets to the power 2 and then plus 6. Well, it's a slightly annoying fraction and not a particularly nice decimal. I'm going to stick with fractions for this. The question doesn't say fractions or decimals, so I'm going for fractions. It is a decimal that stops, so it's not that bad, but it stops after, what, 5 decimal places? I'll stick with fractions for this one. There we are, that's the end of the question. Now look at that, I think that was 8 marks, wasn't it? 2, 2, and then 4. And this pretty much includes everything that you are likely to find in a differentiation question. Part 1, differentiate the function. Find your dy by dx. Learn how to do it. It's the same every time. Multiply by the power, take away 1 from the power. The second thing, find a gradient. All you have to do is put the x value into your dy by dx. Then the stationary point's a little bit more difficult. You have to put your dy by dx equal to 0, solve for x, and then if they do want the y coordinates, you have to put your x values back into the original equation. So maybe not so bad as it looks. The mathematical language of this particular topic is maybe a bit complicated, but you can learn how to do it, and it is pretty much the same every time. So I hope that video was useful to you, and if it was, please go ahead, like and subscribe. I will return in the next video.